This is a demonstration of a class project done for Marquette's Industrial Automation class. Uh, for this class, we used this Rockwell Automation demo hardware kit. It consists of a ControlLogix controller with DC input and output modules, Ethernet IP module, analog inputs and outputs. Then we have it interfaced to two Kinetics 350 servo drives, and those are controlling these two motor axes right here. So the PLC program for the controller was written with Studio 5000 Rockwell software, and also created a HMI to control the system using the factory talk view software from Rockwell. So operation of this system is supposed to simulate a vertical fill, form, and seal packaging machine. So first the motor on the left indexes to pull the film down to create a bag, and then the axis on the right indexes, and that simulates the closing of the cross jaw to seal the bag. The sealing part of the machine is modeled with a heater element that fuses the plastic. So to start this, we can use the HMI in the command screen, and we can turn the heaters on, and we have some inputs or digital outputs here displaying that a start cycle, or that the cycle start process has been initiated and the heaters are on, and it's currently waiting for the heaters to warm up. So that's modeled by this analog knob here. So we can increase that, and now it's saying that the heaters are at operating temperature and it's ready to begin production. And we've also enabled the servo drives. So back to the HMI, we can press start production, and now we see the motors indexing. So this back at the HMI, we can go back to the settings screen, and we can change production parameters, such as the production rate. If we see the max is 200 bags per minute, so we change that, and now these motors are indexing at a much faster cycle rate. We could do things like change the bag length, and that will change the indexing, the amount of the index move for the film pull axis, and now you can see it's actually returning to the same spot with every index. It's actually 4 revolutions, I think it's going through pretty rapidly. And then the cross jaw is a 30-degree move every time. That's also user adjustable. Right now it's actually set at 25 degrees. That can be set anywhere from 25 to 35 degrees. That would adjust that. And so the PLC logic then has a subroutine to calculate the motion profile, ensuring that the indexing of the motion axes occurs at the production rate while allowing the seal time to still occur between each motion, or at the end of the cross draw motion. We also, in the HMI, have a monitoring screen. This is displaying the position of each axis. We have some indicators also showing the drive status. Here, red next to the faulted means not faulted in this case. And we also have a trends display. Here we're trying to monitor the drive velocity, motor velocity for each axis, and the current. The update rate for the HMI though is a little too slow to really get a useful graph out of this. This would be better for monitoring something like temperature or pressure, things that change a little bit more slowly. So back to the command screen, we can, well, first I'll show what happens if it goes into a fault. So if I hold that, now the cross-jaw servo drive is faulted. There's the fault status indicated here too. And on our HMI we have the clear faults button turns red, and we can press that. Now that cleared the fault, no longer indicated there. Now this is kind of in a waiting mode, ready to be enabled. So we can turn the heaters on again, and it's ready for production. So we start production, and we're back in business. Also have a stop production button, which stops the servos and executes a motion servo off command. And then we have a turn heaters off button that we can press afterwards, and that turned off this indicator here saying the heaters are now off. And that's the full demonstration of the hardware. Incorporates PLC programming, servo drive commands, and motion profiles, and implementation of an HMI. That's all. Thanks for watching.